Paging records from an API endpoint. Why API paging? Grid elements like Quick Grid, for example, can handle paging. However, the drawback is it requires you to load the entire set of records from the API to incorporate paging. Instead of retrieving all 5,000 or whatever number of records from the API, you could just pass the page number and number of records you want on a page, and the API will only return for you the 20 or so records you need to display for that page, not the entire record set. That's an obvious optimization for your application. Let's see how we do this. To demonstrate paging in an API, we'll create a Blazor app for the front end and add a web API project. We gave the API the Blazor project name, followed by a .api. In the API project, we added a models folder and created 3 model classes. The student class with a primary ID, student number, first name, last name, and the ID of the course the student is assigned to. It's also got a virtual property that can be loaded if we need to look at the course details. The course model has its primary ID, course name, and course code. Then we have a course header model. This is a little optimization trick. Instead of going and counting every student in a specific course every time, we keep the student counts in the course header table. This does require a little bit more coding. For example, if you add or remove a student, you'll have to increment and decrement the course student count. And also, if you add a new course, you'll have to insert a new record into this course header table. But that's minimal, considering the boost your application gets from not having to go manually count records, especially when those records start running into the tens of thousands and more. We're doing code-first development here, so we create our models, a data context, and then migrate and create the actual database. To do this, we'll need to add the Entity Framework packages to our API. Install the Entity Framework Core package, the Entity Framework Core Design package, the Entity Framework Core Tools, and of course, the Entity Framework Core SQL Server package. Next, we create a data folder and add a Students DB context class. This inherits from Entity Framework Core's DB context. In the constructor method, we'll pass some options from the program CS file when we register it. We add our 3 DB sets for the models. Then, in the onModelCreatingOverride method, we set up the relationship between the student and course table. After that, we seed our tables with some initial data. What's interesting here is that even though the IDs will be auto-generated if we add or insert records later, when we initially seed the database in code-first development, we must specify the ID values. Here's the rest of it. We're just ensuring that the course IDs point to actual course records. In the application settings file, we add a connection string to our database. This database will be created in Visual Studio's built-in SQL server. And the last piece we need before building the database is to register it in the program.cs file. We get the connection string and register the DB context using SQL Server. Remember to build your project. With that in place, we can go create the migration and database. Right-click Connected Services in the API project and select Manage Connected Services. Under Connected Services, select the ellipses next to the SQL Server and choose Add Migration. Give it a name like Initial and make sure the Students DB context class is selected. Click Finish and the migration files are created. Click the ellipses again, but this time choose Update Database. Click Finish to create the database. We can go to the Object Server Explorer and check that the database was created. Again, we're going very quickly through creating a code-first database. We want to focus on API paging, but there is a link in the description below and at the end of the video to code-first and database-first development. Right, with our database in place, we can start looking at generating page data from our API. We'll use a data transfer object to send data to our front end. So add a DTO folder and add a class called StudentDTO. In here, we'll have the student data and some course details. Now we need the service that's going to generate the page data for us. Add a services folder and create a class called Student Services. This class will get our StudentDB context injected into it, and it needs to inherit from an interface. Our central method here is to return a list of students for a given page number and a specified number of students on a page. Our link statement will use the students DB set from our DB context. It then first orders the students by some index. When you use skip and take, you'll always have to use an order by, otherwise you'll get some warning messages when executing this link statement. The skip part says how many records to skip. Here we can calculate it with the page number -1, and that multiplied by the number of students per page. Then from that point, we can take the number of students we want for the page. If there's less students left than the page size, it will simply return whatever number of students are left. If there's no students at that location, it will return an empty list. We also specify no tracking. Usually, Entity Framework tracks changes to records for when you call the Save Changes method. For read-only scenarios like this, we don't need to track changes. This speeds up the query. Then for every student, we transform it into its DTO version, and thanks to the virtual course property on the student model, we can add the course details into the DTO. Finally, we simply convert it to a list and return the result. We'll need one more method to get the number of students per course. We'll need this for when we add filtering by course. Here we pass the course ID, and if it's 0, we sum all the course's student counts. Otherwise, we find the course header that matches the course ID and return that student count. Right, now we can add the interface class with the signatures of our two methods in the Student Services class. And of course, to use this service in our controller, we need to register it in the program.cs file. If you like, you can go test your endpoints with a popular API test package called Scalar. Add the scalar.aspnet core package to your API project. In the program.cs file, add app.map_scalar API reference to the is_development block. Now, right-click your API project and make sure it's the startup project, then run the project. When the host starts, take note of the local host port number. Then open your browser and browse to that port, followed by /scalar/v1. Scalar will show the two endpoints in your student's controller. Let's select the Get Students Count endpoint first and click Test Request. We'll pass it a course ID of 0 to see if it will sum all the student counts. When we click Send, it correctly returns 10. Close this and select the Get All Students Paged endpoint. We give it a page number of 1 and a page size of 2 students. When we click Send, it will return only 2 students for page 1. If we go for page number 2, it will return the 2 students that should be on page 2. As a test, we go for page 4, but with 3 students per page. So, out of 10 students, page 4 should only have 1 student as expected. With our API working, we can go create a page in our Blazor front-end to consume the API endpoints. We'll add a Razor component to the Pages folder. Name it something like Students. Inside, we set the page's navigation route to /students and made the page interactive. In the navmenu.razor file under Layout, we copy and change one of the menu links to point to our new Students page. Now, before we run this, we need our solution to start up both the front-end and back-end API at the same time. So right-click the solution and select Properties. Under Configure Startup Project, select multiple startup projects and set the API project to start without debugging and the Blazor project to start as normal. We can run our solution and see that our students page is working. You'll also notice 2 hosts were started for the Blazor and API project. Next, we need a service to call our API endpoints. We added a Services folder and a class called Student Services. This will get a HTTP client object injected into it to connect to the API. The getStudentsAsync method takes a page number and page size and returns a list of students for that page. Then we set up the URL to the endpoint and call it with the HTTP client object. We added a method to get the student's count. For now, it will just default to course ID 0 and return the count for all the courses. Add an interface class with the signatures of the two service methods. In the program.cs file of the Blazor project, register the service with an HTTP client that points to the local host port of your API. Finally, we can go back to our Blazor page and start rendering the student pages. At the top, we need to use the DTO from the API, and we need our front-end services. We'll inject the student service interface. We're also using stream rendering. Normally, the Blazor page will first collect the data it needs before starting to render, but with stream rendering, it starts rendering the page immediately. This allows us to show a loading message while the data is loading. We'll use a simple table to show the students. In the body part, we iterate through the students list and create a row for each student in the table. Since we need to get the total number of students to calculate the number of available pages, we might as well display these totals. In the code section, we have the list of students for the page, the current page number, page size, total number of students, and the total number of pages. When our page initializes, we get the list of students from the service, specifying the page number we want and the number of students per page. We also use the service to get the total student count over all the pages. Then we use this to calculate the available number of pages. When we run this and go to our students page for the first time, it will show the loading message while retrieving the students for the page. Great, so now we just need a way to change to the next and previous page. We changed things up a bit in the HTML. We're still showing the total number of students. Then we added two buttons for previous and next page. They will call their relevant methods. In between, we show the current page number and total number of pages. The next page method checks if the current page is still lower than the total pages, then increments the current page number. Of course, then we need to call the service again to get the students for the next page. The previous page method checks if the current page is still bigger than 1, then decrements the current page number. Again, we retrieve the student list for the new current page number. We can do the same thing for page size. In other words, we can give the user the ability to change the number of students displayed on a page. We add two more buttons to increase and decrease the page size. The increment method checks that the page size is smaller than the total number of students before allowing the user to increase the page size. Then it gets the students for that page, and since the number of students per page changed, it needs to recalculate the total number of pages. Now, we could reset the current page number to 1, but instead we keep the current page number and just check that it's not bigger than the total number of pages. We do the same thing for decreasing the page size, except we check that the page size cannot be less than 1. This works great. The API will only send you the students for that page, meaning regardless of how many student records are in the database, only the number the user wants to display will be sent back by the API. In this last part of the video, we'll add a drop-down for the user to filter the students by course. Luckily, our architecture is very maintainable and it's easy to add filtering logic. But before we get to that, we made a bit of changes to our interface. We moved the page and page size buttons above the table and added a disabled attribute to them, so when they reach the beginning or end of their ranges, the buttons are disabled. In the code section, we added the bools and their respective logic. Now the user can see when they reach the beginning or end of the pages. To create the filter drop-down list with the course names, we'll need to retrieve the courses from the API. Keeping with our architecture in the API, we add a data transfer object for a course in our DTO folder. Then in the student services, we need to modify the getAllStudentsPaged method to take a course ID argument. In the link statement, we now use a where clause. If the course ID is bigger than 0, then return only students with that course ID, otherwise return all the students. We can also sort by last name and first name instead of course ID. Then we'll need a method to return a list of all the courses. Here we return the course's DB set, but convert all the objects to DTO objects. Ensure that your changes are reflected in the Student Services Interface class. For the student controller, we add the course ID to the getAllStudentsPaged endpoint and pass it to the service method. And of course, we add an endpoint to retrieve all the courses. Right, with our API all done, we can move on to our front-end project. In the student services, we add the course ID parameter to the getStudents method and incorporate it into our URL. Also add a course ID parameter to the getTotalStudents count and use it in the URL. Then we added a getAllCourses method to return all the courses from the API. Again, make sure the interface class reflects the changes to the student services class. In the Razor page, we added Blazor's input select element to create a drop-down for us with all the course names. Of course, you could have used a standard HTML select element if you want to, as long as it calls the onCourseChanged method with the selected value. The value will be the course ID, and we display the course name in the drop-down. In the code section, we added a list to hold our courses and a variable to hold the current course ID. Now we change things up a bit here in the onInitialized method. We call our services to get the courses, then add an AllCourses item to the top of the list that will return course ID 0. We also added a common method to get the students for the page. First, we need to get the total number of students for the selected course ID. Check that the page size is within the boundaries. Then, recalculate the total number of pages and check that the current page number is within boundaries. Only then can we retrieve the students with the proper arguments. The onCourseChanged method simply assigns the selected course ID and calls our new common getStudents method. The rest of the button event handler can also be simplified by calling this method. Now we have a fully functional paged list that can be filtered, paged, and sized. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.